I'm just making up my shaker for going to the gym, and I thought I would talk a bit about the chemistry of one of the things that I am putting in here. And that thing is beta-alanine. You might have heard of athletes taking beta-alanine before in order to buffer lactic acid buildup in the muscles. But let's talk about the chemistry of that process. So this is beta-alanine here. It is an amino acid molecule. It contains a carboxyl functional group here, which makes it slightly acidic. And it also contains an amine or an amino group over here, which makes it slightly basic. But on its own, beta-alanine actually doesn't buffer lactic acid in the muscles. It has to first of all react with another amino acid to form what's called a dipeptide. The other amino acid it needs to react with is this one here, that's known as histidine. And you'll notice histidine's structure is quite a bit different. It's still got the carboxyl group, it's still got its amine or amino group, but it also has this extra amine group on this ring here, the NH group, which makes it slightly more basic than beta-alanine. Both of these amino acids then join together in a condensation reaction where they join with the loss of water in order to form a dipeptide. This dipeptide is known as carnosine, and this is the molecule that's helpful for buffering lactic acid. A dipeptide is just a chain where there's two amino acids joined together, and this amide link here was formed when the two amino acids joined together. Now, the reason that carnosine is useful for buffering lactic acid in muscles is because of this NH group here. Production of lactic acid in the muscles will cause an increase in the concentration of hydrogen ions. If there's high concentrations of hydrogen ions in solution, then what happens is you get the formation of hydronium ions. An excess of hydrogen ions causes hydronium ions to form when it reacts with water, and this is what would give you that burning sensation in your muscles. However, like I said, this group here on the carnosine can help. This nitrogen here has a lone pair of electrons that can actually use to pick up these extra hydrogen ions, which then forms this molecule here and helps keep your pH more neutral. By mopping up the excess hydrogen ions, it can help maintain a neutral pH and stop the burning sensation. The reason you only have to supplement with beta-alanine and not histidine as well is because there's enough histidine in your body already. It's the beta-alanine that is the limiting reagent. So if you give your body more beta-alanine, it can use that extra beta-alanine along with the histidine that's already in your body to produce more carnosine, which means more lactic acid buffering capabilities. So if you like doing high intensity exercise and you don't take beta-alanine yet, then I recommend taking it because it'll give you a little extra time before your muscles start to burn really bad.